Hi everyone, in this video I'm going to be discussing about the logarithmic function, the logarithm. Um, logarithmic function is important in machine learning because machine learning in a way is an optimization process, and we use a lot of logarithmic function in optimization. The reason is because sometimes when you have value that are closely spaced right there, the computer is going to have a challenging time trying to compute, find a maximum or minimum in that situation right there. If you put it through a logarithmic function with small value, to spread out the log a bit more, stretch it out so it's easier to compute. And if you take a look in in this Colab notebook right here, the first thing we do is we import NumPy and Matplotlib PyPlot as PLT. This one is to do the plotting in in Python and Colab. The the next thing is that we want to pay attention to is log or the natural log is base e, right? And e is 2.17, the exponential or the natural exponent. Only and log is only defined for x is greater than greater than 0, and log, yeah, you can see from down here the log increased monotonically to infinity, but it does slowly, and then as it gets closer and closer to 0, the value of it spread out more right there for small x right here. Okay, and and you can have different kind of base. You can have base 2, base e, or base 10. Base e is natural law, and we use a lot of that in machine learning because the natural law of base e is inverse to the exponentials or exponent right here. And then, as I mentioned earlier, log is monotonic, meaning that if x increases or decreases, the log is also increased and decreased. There's no, like for example, the sine function, there's no up and down and up and down. It just increase or decrease monotonically as x increase or decrease. And then minimize, so in that situation right there, minimizing x is similar to minimizing logs of x right there. And in instances where the spread is, where the value is small, minimizing log of x right there might be a bit less challenging for a computer to execute than minimizing x right here, for example. So the way that I plot the log function is that I create a list of 100 data points equally spaced between 0.001 and 5 right there. So this linspace does that. Minimum value, maximum value, and it'll create a list of, in this situation, 100 points evenly spaced. And then the next thing I do is I call NumPy to do the natural log of x and store that in the variable log x, base east right here, log x east right here. And then the next thing I do is that I plot the value. This is the y axis. This is the x right here. And then the market phase color is white. You see this area inside the circle right here, right? If you change it, for example, blue, it's gonna be blue. So in this situation, I do white. And then the shape of the point, I have it as a circle. And this line right, that's right here, meaning that I just connect the connector point right here. And then here's an X label, and there's a Y label, and we'll show it right here. So here's a log function. And you can see it increase monotonically and slowly to infinity as X got larger. And then as X gets smaller right here, you see that the stretch get bigger and get bigger. The next example you can see right here also is that you can also have log of base 2 or base 10 in NumPy as log 2 and log 10 like this respectively. And you can see right here, right, I plot these two logs of using the same data over on here. I plot it in base 2 and base 10. So essentially the log base 2, base 10 or natural log, base e, exponential, it's similar characteristic. The only thing different is that the slope of the log right here And by the way, the legend right here, you can plot, for matplotlib, you can plot two plots on the same canvas, the same figure, and you can also specify the legend right here, base 2 and base 10, right? And so this way right here, which plot belong to which base right here in our example. Finally, to show but not to prove that the natural log is the inverse of the log and vice versa. You can see right here, right? I have an exponential, and then if I take the natural log of the exponential, we get a straight line, like 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 right here. And another thing is that if you do the reverse, right? If you have you take the exponential of the natural log. Here we take the log of the exponential. Here we take the exponential of the log. You see that it'll give us the same straight line like this right here. And by the way, in this plot right here, right, I'm using the LaTeX notation instead of just a regular notation. Sometimes it's going to give us a better presentation of the formula. In this situation, it doesn't make that much of a difference, but in other cases right there, it can present it better. So here's an example of the log function which has its roles and importance in machine learning and deep learning, implemented in Colab using the NumPy library. I hope this helped you. If you like it, please give a thumb up, give a comment, give a like, and subscribe. Thank you, and have a good day.